Hey everyone, hope we're all doing good today. And you say potato? Good, hoo hoo. How's it going? That emote. That Chippy. I haven't seen that one before. How's it going? Alright, so let's see what is new. Oh yeah, this tank problem, that was fun. Shoot, let me... Okay. But Noe! Thank you so much. Welcome in, everyone. You're good, hoo hoo? That's great to hear. I'm good too. Um, scared you? Yeah. My alert scared me too. But no, I hope the surfing went well. See how many of the surfer boys like maths? Yeah. It's really amazing to me that competitive surfing is a thing. It makes sense, but it seems so niche that I never would have expected it. Get record by 1.3 seconds? Oh, nice! I wish I stayed there for just a few minutes more. I had to go get set up for this. Another guy's on to try and beat it. Okay. Uh, but yeah. For everyone who's new around here, I'm Don. I do math and I play video games, and today's a math day for me. So a lot of my stream is me going around on the internet trying to find math questions to answer. But my preference is always to answer questions from people in chat. So when they come up, I always try to get to them first. And right now I'm checking through questions that I responded to on Saturday. And this one I messed up on. I gave this person bad advice, and I realized that, and I said sorry in my second comment. And then this person replied to me and said, I actually was right. I don't know if I understand that. I would love to be right. I don't understand the argument that they're making, though. Hey, first skin, I'm doing good. Oh, Elfstream, thank you for, or Elfstrom? Probably saying that wrong, but thank you for the follow. Okay, so I don't think I have anything that I need to reply to here, so let's look for something new. Okay, might be physics, but we can see. Maybe we can figure it out, because it seems pretty mathy too. Oh, we got German. I assume that's German. Maybe it's not. Actually, is that German? Spetri, if you're still here? I feel like there might be some other related language. Or semi-related, maybe. It's Swedish? Oh, thank you, Elfstrom. I was like, I don't think German has the A with a dot. Oh yeah, I forgot Spetri. I am the expert on German. Of course. Um, I have no idea how you pronounce that last word, but I assume it's some kind of like fantasy creature orc thing. That's what it seems like to me. Tilregalags. Anyway, so 160-meter long movement. Determine the speed when 80 meters has been covered. At what point is the speed equal to the average speed during the entire movement? Determine the speed when 80 meters has been covered. So you would draw, okay, so each of these tick marks is 20. So 80 is this one. Over here where it intersects. Ooh. See, now if they don't have calculus, they could have been taught potentially different ways to estimate this. Like the calculus way to do this would be to find the slope of the tangent line at this point. I guess it would be t equals 5 or 6, 7, 8, 9, 9.2 or something. Kind of mean to give you a decimal. Distance is 80. I guess I guess that works. Just do 80 divided by 9. Does that work though? They've covered 80 meters in 9 seconds. I guess that's basically the average speed up to that point. Wouldn't it be? Because you could do it with the 0.00 and you get that. At what point is speed equal to the average speed during the entire movement? So, well, the speed during the entire movement, you go out to the top, get the end. It's kind of a mean problem to do without calculus, man. Uh, 11, I guess we can call it 11.5 seconds. No, wait. Yeah, no, each tick mark down here is 1. So I guess 11.5 and 160. This is one of those questions where the way they did it is technically valid, but there's many different ways to approximate the slope here. And their approximation doesn't seem very, or it's probably not the best way to approximate it, I should say. Maybe let's redraw this. Oh, that's not. Sorry, I know the view won't be very good for you guys, but let me just draw this quickly and I'll flip it back to the other part. I'm not going to draw it too exact. And about halfway there is 5. Here is 160. Just say about there is 100. And about there is 50, just to get a general scale, but not being too exact here. What they're basically doing is they take the points, they went from the 80 mark about there, went over to the whatever that time is. It was like, they called it 9, which is close enough. And they drew the line from here to the origin. Which isn't that bad of an approximation. You could do better though if you were to take, say, a point on either side of the parabola and make basically a secant line with, well, this is a secant line too, but you make a secant line with points that are closer and get a much better approximation. That's why I'm saying that, like, this feels a bit odd to me, but maybe it was the way that they were taught to do it for the sake of their class. At what point is speed equal to the average speed during the entire movement? Now this part makes me think that we do need calculus or something, because the average speed, you take the first point, which is still the origin, and the last point, and you make the line there, and you do basically the same thing that they did. Let me get a darker marker. Markers are dying on me very quickly. Let's look at their graph just so we can be a bit more exact in getting the average speed. Because I think, like, for part A, it's hard to criticize, I guess. because they may have just been doing the way that they were taught. For part B, if we're focusing on the average speed first we have the point 0, 0. Then up here we have the point, I called it 11.5, 160. Make sure, okay, I'm not covering anything up. Average speed is equal to rise over run. The rise, 160, for the first point, minus the second point, which is 0, over the run, which was 11.5, minus 0. 160 over 11.5, let's just check if that's a clean number. I highly doubt it. We can only let Wolfram give us a cleaner fraction. 320 over 23? Sure. This is equal to 160 over 11.5. I just didn't have a decimal inside a fraction because that feels kind of stupid. Okay, and then now we need to take this number and find where on the graph that basically the slope of the tangent line is equal to that. And I don't know how you do it without calculus, unless you want to do a bunch of guess and check. You could. Okay. The only way to do this without calculus and not spending a bunch of time having to guess and check and plugging in random numbers is we take, so if you do this math, you get 13.91, we'll estimate it as. And that's your slope of a line. So basically what I think you would do is you rise 13 for every one you go over. So you would basically make the slope with your hand or your pencil or something. So if you're going over by 1, let's say that's 1, you would want your entire marker to cover that same distance horizontally and then go up by 13, which is where this is where it gets really sketchy. Then you want to see where exactly that marker only intersects the curve once, which would be somewhere up there, but it doesn't seem like it matches based off my drawing. So that's what I can think of, which basically you make the slope with your hand and you just, try and make it tangents to get a guesstimation. So I will reply to this person because they don't have a reply yet. I do need to ask them how they've been taught to do this though. This isn't this class isn't calculus based. Like this. Depends on how your class was taught. For part A is basically the average speed between t equals 0 and t equals 9, which is a valid estimate for speed when 80 meters has been covered, but you could get a much better estimate if you did a similar calculation with t equals, let's just say 8 and 10, to give an example. If you were taught to do these the way you gave, though, it's not wrong. Because, how do you say an estimate is wrong? in a vacuum. Everything is relative to how much precision you need. For part B, it seems quite difficult to do this. Or it seems like we'll need to use an approximation. If we can't use calculus, since trying to do this exactly would involve a lot of guess and check. I think we would first find the average speed using the points 11.5, 160. The 11.5 is an estimate, and 0, 0 gives a slope of, which is about 13.91. Most convenient way to get an approximation of where the speed is equal to the average speed is to draw a line with slope 13.91 and move it around until it looks tangent with the graph, i.e. only intersects in one point. In case I haven't taught the word tangent yet. Okay. Very weird problem. It's a deleted comment. If we can understand how to do this, we'll post an answer because that comment got deleted and that person didn't, or the original poster didn't reply. So they might not have seen it. Oh God. Okay, this problem won't be that tedious though. It uses the rational root theorem. They call it the integer root theorem, which seems like a bad name for it. Then proceed to find all complex roots. That's a poorly phrased question too, I think, but okay. As they say, the integer root theorem, then find all complex roots, and then they say roots may be integer, rational, irrational, and/or complex, but why they leave out the word like irrational before? Anyway, oh wait, what is this? So they just, this up here seems like the rational root theorem as I'm familiar, where you take, in this case, the 9 and the leading coefficient, the 1, you do 9 over 1, and you do all the factors at the top and bottom too. So you take 9 over 1, you do 3 over 1, you do 1 over 1, plus or minus for all of them, and those are your potential roots that you can manually check. And they found positive 1 and minus 3, I guess? Or negative 1 and positive 3? Okay. I don't know what this is. I guess it's some form of division that I haven't seen before. F of negative 3 are not equal to 0. I guess let's check the roots this person got, uh, the integer roots this person got. So we have x to the fourth. I should have looked at more. X to the fourth plus 3x cubed plus 2x squared. 3x cubed plus 2x squared plus 3x minus 9. A weird looking function. So it's -3 and +1 for the roots. So they did flip the signs, but this person, f of -3 is equal to 0, unless this person is very, like, adhering to logic and using the word and in, like, a logic sense. Oh, wait, no. It depends on how the person initially phrased it. This person might still make sense, but it's hard to tell when I can't see the initial one. Let's just, I guess, even though it's... Actually, so how do they get... I think I made a mistake with flipping the sign. Because they got -3 as a root, but then they put +3 in for the final answer. As far as I know, the rational root theorem, it does get you the final root. Hey, Skirtle. How are you today? So -3 is your root, and you would divide by x plus 3, which they seem to do. They just, maybe when they did x plus 3, they accidentally flipped the sign. So let's take this, and let's divide out x plus 3 as they did, and see what Wolfram Alpha gets us, because I could do this myself, but it's just kind of a pain. Oh, I could have just looked at the the final factor result on the last page, I'm sure, but you're doo-doo today, but you'll be working? All right. Hope you feel better. Thanks for lurking. Okay, so this person should get x squared plus 2x minus 3, which they get. Okay, let's divide out x minus 1. Oh, and we'll get x squared plus x plus 3. Good. And then they do x cubed plus 3? And then they take the square root? Those emotes are very cute, yeah. Who's jealous? I have no idea how they did this last part. They should just use the quadratic formula though, because this isn't factorable. The complex roots are that. So let's write back to this person and say, integer root theorem or rational root theorem. I'll just use the language that they used. That you flipped the signs when plugging them into the website. Your integer roots should be -3 and +1, right? Yeah. Flip the sign if you obtain the roots via the integer root theorem. The sign for this question. However, your other math is correct up until you find the roots of x squared plus x plus 3, was it? Yeah. I'm not quite sure what happened. Did you set that x squared plus x equals x cubed. That's what it seems like they did. They said we went from x squared plus x plus 3 to x cubed plus 3. The only way I can think of is if they accidentally added the exponents for x squared and x. If so, that part is where you went wrong. X squared plus x can't be combined any further. You only add the exponents like that if you have multiplication, like x, squared, not capital X, times x, rather than x squared plus x. You get to the stage with x squared plus x plus 3. You can't factor it with other methods, so I would just use the quadratic formula, and you will find the two remaining complex roots. There we go. Bit of a long explanation, probably longer than it had to be. But I already hit save, so I'm just going to go with it. Because with the way that they phrased it, there's a lot of different possibilities. In the inverse of y equals x squared plus 4x plus 3, where x is less than or equal to negative 2. I think I already know the answer to this. Let's actually show it, though. And this is going to be... This person technically did the problem right. They just missed one little subtlety here with when you square both sides of the equation. In the initial condition, we were given of x less than or equal to negative 2. We have y equals x squared plus 4x plus 3, where x is less than or equal to negative 2. Okay. So, is there an easier way to get the inverse of this? I mean, okay, first I'll graph it just so we can see what it looks like. This factors out to x plus 3 times x plus 1. So our roots are going to be at negative 1 and negative 3, just guesstimating. And the leading coefficient is positive, so parabola is facing upwards. But x is less than or equal to negative 2. So we only have the left half of the parabola and not the right half. So let me actually erase that. Okay, and so we do need to find the inverse of this function. Hey! Thanks so much for popping in. No worries about working. I appreciate that. Hope you're doing good. Yeah, Tay is avoiding hard locked. Inhumanity. They hide from me. So when we go about finding the inverse of this, you switch the x and the y's, and then you solve it for y again. So if we switch around the x's and the y's, I don't know how this is going to work out, but you get x equals instead of y equals y squared plus 4y plus 3. And like, how do you rearrange that? Um, just busy roller. No worries at all. I'm sorry, I can't talk. Hope you're able to get your work done, and thank you for the well wishes. Happy to have you here too. Is Hardlock God? I think he is God. Okay. Thanks for coming by, Tay. How do you solve that? Do you put it? Oh, maybe you need it in vertex form. That's the key. But okay. Before we even think about switching the variables, which it actually wasn't too late from the stage that I had. He wishes. uh, let's let's take this equation, put it in vertex form. That's a much easier way to get to find the inverse of this parabola. So when you want vertex form, you have to complete the square. So we take minus b over 2a. B is 4, a is 1, our square is 4. We have to do plus 4 and minus 4, and the plus 3 is still there on the end. And basically, we're going to factor this part. Y equals, this factors to x plus 2 squared. That's what we call completing the square. I didn't really explain that well, but just bear with me. Now this will switch the x's and the y's, and how we simplify it is much more clear. Y plus 2 squared minus 1. Now we add 1 to each side. I'm not covering up my math, right? Okay, good. Then we square root each side. And here is where they actually went wrong. So when we square root each side of an equation, we have to do a plus and minus on whatever gets, like whatever still has the square root. So we have to do plus and minus root x minus 1 equals y plus 2. Now let's bring the 2 to the other side and flip the equation to get y equals on the left, because that's just how I like it. Plus or minus root x plus 1 minus 2. Okay. Hey, Druha. So I agree with the answer this person got. Up until the whole, or I agree with like this, or we got basically the same equation. I still have the plus and minus in mine. They took the plus, but as they discovered, you're supposed to take the minus. And that's because we have to go back to our initial condition of x is less than or equal to negative 2. So we only have the left half of this parabola. And when we find the inverse of it, it basically gets reflected across the line y equals x. And so we would expect the inverse to look like that, because that's just what happens when you, or I guess when you reflect it from one end to the other. The other half of the parabola looks like this, and it goes on both sides of y equals x, and it's just, it's not the reflection, I guess. Probably a better way to explain that, but that's why you had to take the minus part, because the minus part correlates with the lower half, whereas the plus part correlates with the upper half of the parabola. It's a weird, finicky thing with horizontal parabolas that you have to remember to that. You have a plus and minus because of the way that we've defined functions for the math that we normally do. Let me refresh this page to make sure that no one else beat me to it. Someone beat me to it. Dang it. Let's see what their answer was. Maybe I'll have something to add, though. Sunny Tab said it's true. I want to explain it in my way, though. My way is better. Thank you, Hardlocked. So I have a beard and he doesn't? Yeah, that's true. I heard Sunny Tab does not have a beard, and that's a huge issue when you do math. I'm a little bit scared telling you about this Hardlocked, but I did finally add channel point redeems that play sounds. I only have 4 so far, but You might have fun with those. They are like jump scares though, but I do have all these like little sounds that you can play like that. I'm gonna try and add more. Special Ed Sheeran beard, yeah. You were first. I made it only redeemable once per stream, so I figured it should be special. It was Spetri though. He wasn't even first. This is the first day that I've even had them, so no one knew that they were there. Someone cheated? Yeah. No, I told Spetri about the redeems. He wasn't even first, so I'll throw an Ed Sheeran joke, but you're too late. Yeah. Um, take the plus sign with the square root. We get the upper half of a vertical parabola. And if we take the minus sign, we get the lower half. Oh, not vertical, but horizontal. Need to check each one for which makes sense for being the inverse. Remember that an inverse function should be reflected across the line y equals x. Okay. My explanation is a bit more specific, which is why I wanted to post it. Let's see what this is. Oh god, one of these word problems. Wait. 1/3 of the original amount plus 5. Okay, we can do this. Why not? For this, you really just have to be careful about how you define your variable, so you keep things consistent. So how much money did she start with is what we want. X is equal to starting money. So there's 3 different purchases, and we have some leftover money. How should we set up this equation? So if we're left over with $20, let's put 20 on its own. And that means it's going to be X, the amount we started with, minus whatever we spent, because our initial starting money minus whatever we spent equals the money we have left over, which is 20. So our first purchase was 1/3 of the original amount plus 5. So 1/3 of X plus 5. Is it 1/3 plus 5 of the original amount, or is it 1/3 of the original amount? I guess 1/3 of the original amount plus 5. Okay. I was wondering if we technically need parentheses there and there, but I don't think we do. I think I'm overcomplicating it.
first purchase, plus 1/3 of what was left plus 5. So 1/3 of what was left, which is not the same thing repeated here. X minus 1/3 x plus 5. It's going to get complicated. Plus 5. And 1/5, I assume, of what was left after the second store, which is going to make it even more complicated. Is there a better way to do this? That's be a more efficient way to set up this equation, right? I think it's better to do this not overly algebraically. How about this? I could set up a whole equation with x's and stuff, but that's just going to be a huge, huge pain. And we can do this in steps instead of trying to put it all in one equation. So first purchase. Wait, no, can we do this in steps even? This is such a weird problem. I hate it. That, like, I want to come up with a way that's more efficient than just, like, doing it brute force. Or it's the way I was doing it feels kind of brute force. Original amount plus 5. Maybe you do need it all in one equation, and I'm crazy. It's getting so complicated. Like, like the ways to find is annoying. All right. I guess actually I was on the right track at first. Let me just quickly rewrite and just deal with the math. So x minus 1/3 x plus 5 plus 1/3 x plus 5 plus 5. I know a way to do it, Druha. I just wish I knew of a better way. So if you do have a better way, I'll gladly hear it. Or maybe do it backwards rather than forwards like I was thinking. Okay, yeah. So if we did it backwards, I mean, you have to do like some substitutions, right? 20 equals a fifth of second. Not plus anything. And then if we go down here to second, is equal to a third of first plus 5. And then we do a substitution for second? That seems weird that we don't get an x there. 20 equals 4 over 5 of x. Well, it's not... How do we define x? Yeah, okay. What I did is wrong, but how is x defined in your way? So we wouldn't use... If we're doing it like that, because it's 1/5 of what was left after the second purchase, which is what's confusing me. Not 1/5 of the total initial amount. That's why I was doing this weird thing with like... Okay, if I just shut up and listen to you then, what is that? Is equal to 4 over 5x. No, not 80. Why would I put 80 there? Wait. No, it is 80, isn't it? No, it's not. Why can't I do math right now? 25. There we go. Okay. Hey, Jed. You swear you weren't cheating? Oh, you were watching another streamer? I don't know, Jed. You got that other math streamer smell. I don't know where, like... Okay, so she spent $5 and left over with 20. I guess that makes sense for where you got the third equation. He was doing logic yesterday. He's still my math guy. Oh, Penn Center? All right, Penn Center's cool. I can't be mad. I guess. And that hurts me more, Jay, because just for you, I finally got a channel point redeemed so you can play a little Siren for me. We had a nice chat. Oh, that's awesome. You did geometry when you turned on the stream? Oh, okay. So you instantly left. It sounds like you missed out on the set theory then, Jura.
Oh my.
Oh, there it is. Oh my. That's gonna surprise me every time for a while. There, yeah. That way, when I'm too busy doing the problem to look at chat to realize that I made a mistake, you can beep at me. They're on a 10-minute like timer for now, so you can't like spam it. But I might change it depending on how that goes. But okay, if we have a well, okay, I started making it a whole equation. I realized that we can just work backwards. But I'm kind of stupid, so working backwards is like is weird to me, but working backwards is definitely the answer. Let me make sure that no one else actually beat me to it in time that I was taking being dumb. Okay, no one else has posted on this yet. 2/3 y minus 5 equals 25. It's weird that we're doing it reverse. That's what's getting me like caught up. So 25 is from the previous one. And we have $25 left over after we spent a third plus 5. And that's what we have to do, kind of like the reverse, I guess. So y is equal to 45? 30 times 3 divided by 2. Yeah. Okay. And then for the first one, we do the same thing because it's the same numbers, right? So $100? I guess it makes sense. I just thought it'd be more complicated. Why you gotta make things so complicated? That can't be right? Dang it! Oh. Wait, 50 times 3 is 150. 75. God dang it. I was doing 2/3 of 150 instead of a half. There we go. A third is 25. Plus 5 is 30. So that's why we got 45. There we go. And of course I got beaten by 2 people. Yeah, see, now I really can't blame you for watching Penn Center. When this is the standard of math that I'm doing. Hey, this is what I was doing. That's true. Yeah. I guess I will. I didn't mean to say yeah, that's sassily. But okay. And thank you for calling it my work backward solution and not Truha's. It's definitely all me. Um so 'and Jenny, and I'll give them the first step of working backwards and leave the rest up to them. So I do agree that Farkle, with like what Farkle is saying too, like they should say where they're stuck and not just ask for a solution. Um, 20 equals 4 over 5x, where x is the amount Jenny had after leaving the second store. So x is 25. Maybe I shouldn't over-explain this. Verify by taking 1/5 of 25. That you're left with 20. Well, punishing sound, it's not a single comment, only good check. That's true. I mean, I only myself to blame if I get annoyed at the alerts for that reason. um, the oh my one does make me laugh though. So I guess it's not like, I guess it is more negative than positive probably if using it as a reaction to me, but it at least makes me laugh. The most positive thing I could say about the alerts that I set up. Well, there's the one for first, but that's only once per stream. That one's just funny. Um, okay, how about this? Also, I didn't wait for a response from anyone before just posting it, so. Why is this clear? The classic book saying something is clear when it's not obvious. That's why I don't like using the word obvious or clearly if I can help it. Hard lucked. Let's go math. Hope you're doing good today, man. You're good? Awesome. A sub n minus 1. A sub n minus... What the heck? The a sub n denote the positive integers whose digits are chosen from 1, 3, and 4, in the sum of whose digits are equal to n. We need to look at an example of this. I feel like I can figure this out. Actually, this post is really new. I'll make sure no one else is beating me to it. Okay, good. Okay. So a sub n is some number whose numbers sum to n, or digits. I can't spell. The digits belong to 1, 3, and 4, and sum to n. So if we have a sub 1, we have 1. A sub 2 is 1, 1, because that adds to 2. A sub 3 is 3. A sub 4. Aren't there multiple? Can we have 1, 1, 1, 1? And can we have 1 and 3? Or 1, 1, 1, 1? I assume it's the least number of digits. Maybe they put a dot 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 after that part, so maybe they were a bit more specific, or like the book was more specific than that person was including. A sub 5, it could be 4 and 1 or 1 and 4. I don't know how you distinguish between those. But let's go out like a few more. So it'd be all permutations of any valid number. One, 1, 4, or even 3 and 3. Okay, this is a little ridiculous. or maybe they say something about no repeats, or it has to be in order of 1, 3, and 4, and if you can't make it something that sums to that, it's just not a valid A. I don't know. Uh, um, I I think I'm gonna leave this one open for a bit to give it a few minutes to see if someone else responds. And if they don't get a response in a little while, I'll type in my thing of not ask. Like I want to ask them what's in this dot 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 if the book was any more specific on what a sub n should be. Oh, you know what? There was no one else commented on this one. I wanted someone else to like comment on this because in the way that I was looking at this one earlier and I was just trying to find examples of a sub n. And with the way that they've set it up here, there's multiple possible solutions for, say, a sub 6. It could be 114, 141, 411, or 33. And I feel like there's no way this relationship can be true, I don't think, unless you put some kind of other constraint on a sub n to eliminate the extra possibilities. And I was hoping someone else would reply back, because I'm not like that confident in saying that. But no, it's been 36 minutes and no one has replied. Yeah, Jed, so I worked out A1 through A6. And for a lot of them, there's multiple possibilities. So my theory was just, go up to like A7 or A8 or something and see if I can verify this formula, but I don't know which one you're supposed to use when there's like 4 possibilities for some of them, if not more. Because if one number works, all of its permutations also work, assuming that repeats are allowed. But if you don't allow repeats, then you can't make every single integer or so. Maybe I will just reply back. Is there any other constraint? Certainly doesn't seem clear to me either, especially since something like no, I think you just mean like a subscript 6. And well, I mean, oh, I see what you mean with being a set. I doubt it. I feel like it's just supposed to be one number if they're talking about sequences like this. Yeah, we'll look at more because we didn't have either of you here when I first looked at this problem, so maybe one of you will have a better idea of it. So the way I'm interpreting the problem is for this, a sub 1 just has to be 1. That's the only possibility I can come up with. A sub 2 has to be 1, 1, because we're only allowed to use the digits 1, 3, and 4. I made the same typo again with digits. And sum to n. So then a sub 3 has to be 3, or in theory, 1, 1, 1. And you can have this 1, 1, 1 thing for literally all of them. which I didn't leave off my little thing for a sub 6 there. A sub 4 could be 4, it could be 13, it could be 31, it could be all ones. A sub 5 could be 1, 1, 3, all of its permutations could be 1 and 4 in its permutations, or all ones. A sub 6 could be, I mean, I have the patterns being clear, but 33, 1, 1, 1, 1, 1, 1. So, and so on like that. And so like, oh, you're right, Jed. Yep. You could replace 3 of these ones with a 3 in all the permutations of those. Which, it's not that hard to write out. And so maybe we could choose numbers such that the sequence a sub n is equal to an minus 1 plus an minus 2 plus an minus 3 plus an minus 4. It certainly doesn't seem generally true, though, or I don't know how even... A sub n seems ill-defined. Denote the positive integers whose digits... I guess a sub n, it must be a set if it's positive integers, plural. What are you talking about that, Jed? One, 1, 2, 4, 6, 9? Oh, if we are doing about cardinality. Okay. One, 1. Yeah, so if we write that, the cardinality 1, 1, 2, 4, 6, 9, 3, 3, 3. I mean, we have to go back by 4 of them, so this should be equal to 6 plus 4 plus 2 plus 1, which that's certainly not true. Oh no, I skipped one. There's no a sub n minus 2. Or I added one, not skipped one. I did. Okay, you're right. A sub 4 has 4. Okay, yeah. So now this does work, because 9, 2, 1 makes 9. Or 6, 2, 1 makes 9. Okay. Well, I mean, now that we've drawn it out, we can see the pattern. If we... A sub 7 is going to be a little bit too annoying to want to do out, but... Okay. I think that it does give me some confidence to reply back. I didn't think to wonder about the cardinality for sure. I mean, we would expect it to have 9 plus 4 plus 2 is 15, yeah. I mean, I don't want to actually like test it, but based off the formula, that's what we would expect. figure out why? You know why? All right. Like, I'm okay. I don't want to figure out why. Maybe? If you want to say, then sure. I don't know if the y is relevant to actually this certainly should not be clear that a sub n is equal to that. And it and that equation certainly wasn't clear to me either. The a sub n minus 1 you add 1 to get to set a sub n. Okay. For a sub n minus 3, you add a 3. The equation is wrong? Oh, if we tried it for like a sub 7 and so on, would it not be right? All right, let's try it for a sub 7. You guys have sufficiently piqued my curiosity. I mean, I doubt it's for combinations versus permutations. That would be really weird. I guess it could be. Like the problems we already said the problem is super weird. Let's get a 7 though first. 43, 34. Let's try splitting up the 3's into 1's. 4, 1, 1, 1. 1, 4, 1, 1, 1, 1, 4, 1, 1, 1, 1, 4. Split up, I guess, the 4 into 1. This blows up pretty quick. Then doing the same thing. Actually, with that one, it should be the same as all these. Okay, that saves some time. Doesn't work with combinations? Okay. Give you 3 minutes, Drew. Okay. We got 113 and its permutations. We got 1, 2, 3, 4, 5, 6, 7. We've got. Do I already have 4, 1? No, I don't. Yes, I do. Is this everything? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that holds with the pattern there for a sub 7. You can ask me to do a sub 8. You hop in voice with me? Yeah, sure. Let me just check my Discord mic. I'll hop in there in a second. Okay, good. Hey.
Hey, Don. Can you hear me okay?
Yeah.
Okay. So what I'm getting at is if you look at the equation a sub n is equal to a sub n minus 1, or yeah, plus a sub n minus 3 plus a sub n minus 4. What you can do is if you look at, let's look at this case for 5, like this is a trivial case, right? Or yeah, I guess, or 4 is the trivial, a sub 4 is the trivial case, right?
Well, a sub 4, we're not defined anymore.
Let's stick with a sub 5. Let's stick with a sub 5. So what you did is you took everything from a sub 4 and you put a 1 in that set, right? So you have a 4, so you make it 1 4 and 4 1,
okay,
right?
Yeah.
Or you got 1 4, you got 1 1 3, you got 1 3 1, you got 1 1 1 1 1, right? And then you did the same thing with a sub 2. You added a 3 to that set, so you have 1 1 3 and the various permutations of that, but they cancel out a lot with the previous one, so you have to take those out. And then with the a sub 1, you're adding a 4 to that list, which is what gives you the 1 4 and the 4 1. So you just have to figure out, you're adding a 1 to everything with the n minus 1. You're adding a 3 to everything with the n minus 3. and you're adding a 4 to everything in the n minus 4, and then removing all the duplicates,
Okay.
right? So if you look at a sub 4, if you just list those on the left hand side of the board, maybe the 4, 1, 3, 3, 1, and the 4 ones, and you just add a 1 to each of those.
4, 1, 3, 3, 1, 1, 1, 1, 1. And then we add a 4 to each of these.
You're going to add a 1 to each of
Oh,
those.
1.
So you're going to have a 1, 4, a 4, 1, and then a 1, 1, 3, a 1, 1, 1, 3, and a 1, 3, 1, because there's 3 different places you could put in there, right?
Yep, yeah.
And then the next one, you got a 1, 3, 1, a 3, 1, 1, and a 3, 1, 1.
Yeah, okay.
And then, of course, the 1, 1, 1, 1, you could add a 1 into 5 different places in that, right?
Yeah.
So, but it's, you're going to have duplicates in here, and you just got to figure out what those are. Then go to the a sub 2, and you're going to add a 3 to that, right? So you got 11. You're going to add a 3 into that mix.
Wait, for a sub 2?
Because you're doing
Okay.
a sub n minus 3. So n is 5, n minus 3. 5, n minus 3 would be 2. So a sub 2, you're left with a 1, 1, and you're going to add a 3 to every possible location in there, right?
So then we see with this one, with 3 and 1 and 1, we added 3 here, and that correlates to some of the.
Oh, no, we don't. A sub 2 doesn't have a 3.
Oh.
A sub 2 is
Oh,
only
yeah,
1,
yeah.
1.
You're right.
And you're going to add a 3 to that list somewhere. So it's going to be 3, 1, 1, 1, 3, 1, and 1, 1, 3 as your 3 possibilities, right?
Oh, okay.
And then go back to a sub 1, and you only have one thing in there, and you're going to add a 4 to the 2 possible cases there.
Okay.
But then you've got to eliminate some of those duplicates, right?
Right.
So, and you got to figure out, so how do you know that? So a sub 4 and a sub 1 is going to be covered by a sub 4, because you're adding, in one case you're adding a 1, in the other case you're adding a 4, and you get the exact same set. So I'm not sure if there's a relationship there that you can kind of work out, but basically that's kind of what you've got. These sets that are, you're adding a 1 in one place, you're adding a 3 in another place, you're adding a 4 in another place, and then you have to resolve those conflicts. And how many different conflicts can you have? And I think everything's going to be duplicated, right?
I guess so.
Is that correct? We
This
get a
is-
sub 5 has a cardinal of 6, and you've got
So we get way more
14
than
different
6 things.
combinations.
Yeah.
You got 14, right?
So I guess that's why I said it might be combinations instead of permutations.
It can't be combinations because I did the math on that, and the permutations don't follow.
Oh,
The
yeah.
combinations don't follow the equation.
I do see where you're coming from with that, though.
Yeah, but so you do have some duplications, and you just got to figure out, how many. Like you can see the 1, 3, and the 3, 1, and the 1, 1 all have a lot of repetition. Actually, they're completely repetitive, right?
Yeah. Huh.
So I'm
Eliminate
sure there's
duplicates,
some
get
formula you
eliminated.
can come up with it, the intersection of all those, and try to figure out, that's my take on it anyways. I mean, it's no secret that, if you're adding 1, 3, and 4 to the set, you're going to be using the previous set, the 1, 3 back and the 1, 4 back, because you're adding a single digit to each of those sets. I don't know if that gets you any closer to a solution, but just an observation.
Okay. Yeah, it's definitely interesting.
Actually, we have more than 14 because you didn't draw out all the possible combinations of 5 1s. There are 5 different combinations.
That's true.
So we're actually at 18 different possibilities, correct?
Yeah, if all the ones are distinct.
Because you got 5 different
I
combinations
mean,
for.
would it also be
where you
true
can put
for
that.
any repeateds?
5,
Like
3,
the
3,
3, 1,
2,
1
3, 2.
would actually be 2?
No, you got 3 combinations. You put the one at the front, in the middle, or the end.
Oh, I guess so. Yeah, it's already covered by the others.
Right.
Huh.
So in total, you got on the top line 2, 3, 3, and 5. That's 13, right? And then 3 and 2 more is 18 total answers. But of those 18, you have, that's 3 times too many, right? You got 12 duplicates in there.
Yeah, and I mean, just like even the top line, just it covers all the possibilities for a sub 5. It's almost like we don't even need the others. I don't know.
Does that hold true for
It might
all
hold
of them?
true.
I doubt it would.
Oh, yeah, it might just be a coincidence because it's so simple.
Yeah, we're kind of looking at the trivial case here. Well, relatively trivial.
As trivial as
Because
it
you got
gets for
n minus 4, you have to go at least at 5 to. Because I don't think
I guess
the.
it can't be true for 6 because some you like the digits are well actually.
Well, if you look at a sub 5, 1, 1, 3, 1, 3, 1, 3, 1, 1, if you add a 1 to all of those, you're going to get a lot of repetition in just those.
Yeah. I guess the only like distinct one for a sub 6 is 33 that you can't directly get from a sub 5. It has to come from a sub 3.
I wonder if you can use something about you've got a set of numbers and how many different combinations are there or permutations, unique permutations are there of that set of numbers. So like you have the set in a sub 5 of 1, 1, 3, 1, 4, and 1, 1, 1, 1, 1. And how many different ways can you arrange those three sets uniquely? And maybe it has something to do with that. That's getting more complex, I guess, but
Yeah. I mean, either way, the book says it should be clear, and it's clearly not clear. But like the person said, the book said that it's clear.
yeah, I mean, I don't know if you can actually, let me ask you this. If you let's at the bottom left corner of the board there, start again with a sub 4 and just list those. Just 4, 13, 31, and 4 ones.
4, 13, 31, 1, 1, 1, 1. Okay.
And then put a 1 at the end of each of those. Just at the end of it. So
Okay.
it become 4, 1, 1, 3, 1, 3, 1, 1, and 5 ones. Do the same thing with a sub 2. You've got a 3 and a, or no, excuse me, you got a 1, 1, right? In a sub
Yeah.
2, you got 1, 1, and we're going to add a 3 to that.
Oh, 3? Okay.
Yeah, because we're at a sub 2, we need to add a
Oh, yeah.
3 to get back up to 5.
That's
So
right.
it's
Yeah.
just 1, 1, 3. And then do the same thing with a sub 1. We start with a 1, we're going to add a 4 to it. And that's your solution, right? And all the combinations are satisfied in there. You just appended a 1, a 3, or a 4 to those solutions, because if you put it anywhere else, it's already covered somewhere else, because you've already covered 1, 3, 1 in the a sub 4 list.
That might
And
be it right there. Yeah.
you could do the same thing with if you wanted to instead of appending, you could prepend it. So instead of 4, 1, 1, 3, 1, 3, 1, 1, and 5 1, you could do 1, 4, 1, 1,
Oh,
3, 1, 3, 1, and 5 ones. Because in the next one, you're going to have the 3 is going to be prepended to the 1, 1. So you get 3, 1, 1, which you won't get in the earlier set because everything in the earlier set starts with a 1 if you prepend. In this case, everything at A4 ends with a 1 when you move it to A5. Everything at A2 ends with a 3 when you move it to A5. And everything at A1 ends with a 4.
okay.
So that may be actually the solution we're looking. So then if you look at A7, you're going to take everything at A6 and just append a 1 to it. That's going to give you 9 solutions. You're going to take everything at A4 and add a 3 to the end of it. That's going to give you 4 more. And then you're going to add in A3, you're going to take everything there and add a 4 to the end of it, and that gets you your full set of solutions.
That must be it. Yeah.
So we don't even have to worry about the possible permutations as we do it. Just appending that 1, 3, or 4 gives you a unique list. And because you're appending, you won't have any duplicates, because in the case of a sub n minus 1, you're appending a 1. So all of those answers are going to end with 1, and nothing else is going to end with 1. And then when you do a sub 2, or a sub n minus 3, I should say, you're appending a 3 to the list, and so that's going to be your unique list of answers that end with 3. And so there is no repetition.
Okay.
Does that?
That makes sense.
And you could do the same thing for any combination.
Mingo,
If you want to do
welcome
1,
in.
4,
Yes,
and
it
5
was.
as being your unique digits, then it's going to be
Glad to
a
have
sub
you.
n is a sub n minus 1 plus a sub n minus 4 plus a sub n minus 5, and you get the exact same solution.
Okay. I guess, yeah, that explanation makes this equation a lot more clear. Jura said he's like gonna manually verify with the computer, which I'm interested to hear if it holds up with that. But I
Oh,
don't want to manually check it past that.
You're not going to write a Python script to do this?
I'm okay. I can handle like 2 plus 2 and, you know, sometimes division, and that's about it with Python.
But I guess, I mean, if you look at it, every number in the set has to end with a 1, 3, or 4, correct? Because those are the only 3 digits you have
Yeah.
available to you.
Right.
So if you take everything in a set that doesn't end in 1, or that, you know, everything in the previous set and add a 1 to it, then the sum is satisfied and it ends in 1. If you do the same thing with the previous set, the a sub n minus 3, and add a 3 to the end of it, you're satisfying the sum because you're adding 3 to each number, and you're getting all the solutions that end with 3. And I
Oh
guess,
yeah.
like I
So
said, yeah.
okay, yeah.
So there's, you know, like if you look, you know,
That's why there's 3
anyways,
terms. Okay.
right? So like, yeah, and you're guaranteed uniqueness because the number you're adding goes on the end. And again, it works both ways. You can put it on the front. If you want all the solutions that start with 1, then you just prepend the 1 to all the previous, prepend the 3 to all the ones in minus an a sub n minus 3, and prepend a 4, and you're guaranteed that all the answers are unique.
All right, that's clever. And you make an applause thing.
I think the key to this working is the fact that the numbers are all. I'm trying to think of what the right term is, but you couldn't do this with 1, 2, and 4
With 1,
because
2,
you could always substitute 2 2s for a 4. So the numbers
oh,
are,
they need
I
to
guess,
be.
relatively prime. Is that
I
the
guess
right
so.
phrase for that, or?
Yeah.
Because if you threw 2 into the mix, then it wouldn't work because you could always sub in 2 2s for a 4 in any of the.
Maybe
Maybe I
there's a
don't know.
different way that
I
you
haven't
could
proved
do
I
it.
haven't
I'm not
proven
saying.
that yet.
Yeah.
But a slightly different way of thinking about it, I guess. I don't know.
Okay.
But it logically makes sense. I guess you could probably come up with a theorem.
Probably. Not
Say
me, but
the number must end in 1, 3, or 4. If it ends in 1, then the remainder of that number must exist in a sub n minus 1, right?
right.
If it ends in 3, the remainder of that list has to exist in a sub n minus 3.
Yeah.
If it ends in 4, it must exist. The remainder must exist in a sub n minus 4 for all n's greater than 5, right?
Yeah.
And then you know that they're unique because the only things that end in 1 are in the first set, and the only things that end in 3 are in the second set. And the only things that end in 4 are the third set. And you know there's no repetitions in the a sub n minus 1, a sub n minus 3, a sub n minus 4. So you know that every answer you come up with is unique. And I don't know if that's sufficient to prove that it's complete.
I
That there
don't
aren't any
either.
additional solutions. I mean, I guess the fact that if there was another solution that wasn't included in it, then you missed it in the previous set. But I'm guessing
Yeah.
the question is regarding the cardinality, and that's probably how I would do that.
Yeah. So I guess it's personal need to prove anything. You just need to know why that formula is the way that it is. So I think we've covered that much at least.
I like this. Like it was fairly clear that this is the truth. This is the case. It's like, yeah, fairly clear doesn't work in mathematics. You have to prove it.
Yeah.
If it's not proven, it's not true.
Sometimes I wish that wasn't the case, but yeah.
It's like it's fairly clear that you know, whatever, into the zeroth power is 1. Well, is that fairly clear?
Yeah. Exactly.
That's what I got for you. I'm looking forward to seeing Drew has code.
Yeah. Me too.
All right, thanks for the chat.
All right. Thank you. Bye.
Bye.
Okay. Uh, so I'm gonna start typing out my answer, but Drew, I'll wait to post it until you're able to do your thing. And Mangoes, I'm sorry I wasn't able to talk to you like at the time that you chatted, but I appreciate you coming by. Abstract algebra is your one and only true love. It is not my one and only true love. Maybe I one and only true hate. Well, it's not even the one. It is a true hate though. I'm glad that you enjoy it, and there are people who enjoy it though. I much prefer like
applied math. Okay. Problem doesn't seem phrased well. And that equation wasn't obvious to me either. Sounds true love is taking a picture of Shep's leg after she dies. To be clear, that's in a video game. But yeah, I have accidentally taken a picture of some legs in Phasmophobia. And she's wearing pants, yes. Full disclosure, yeah. Thank you, Jed. You dig me a hole and then you get me out of it. Okay. Like a sub n is the set of integers, or it's the cardinality of the set of integers with digits 1, 3, and 4 that sum to n. For example, a sub 6 has, or I guess a sub 6 would equal 6. Equals 6 since there are, wait, no, a sub 6, no, let's do a sub 5. A sub 5. That's what I want to. I want to do the one that resulted in 6. Oh, yeah, sure, Drew. Let me, I know which part of it you need, but there. What's the volume of the displaced dirt in cubic meters? Is that is that a reference? I'm trying to remember it. In the whole, oh, I see. Yeah. Exactly, that'll be the next problem. Sure, I assume you only need like the part of the board by me. I'm gonna cover up the part of the screen on the other part, so I can keep on typing out my answer. Hopefully that's enough for you to see. Or if not, just let me know and I'll figure it out. That's true. Since there are 6 elements in 113, 131, 311, 14, 41, 1111, 1. Man, this is hard to explain if we don't show out. I guess we should show a sub 1, a sub 2, and a sub 4. To apply a formula with a sub 5, let's find, do I use Red and Hammond 2 in my browser? No, I don't. I've never tried any of the extensions like that. It might actually improve it. I just have never tried them. A sub 1 equals, or a sub 1 equals 1 with 1. A sub 2 equals 1 because of 1, 1. Your testing proved the formula to be correct. Okay. Nice. I don't know how you programmed it, and I feel like I don't want to know. A sub 4 equals 4. 4, 1, 3, 3, 1, 1, 1, 1, 1.
see from this easiest case that 4 plus 1 plus 1 equals 6. So that checks out. Drew is saying, yeah, Jed, you're right. Jed's quest is to make the world admit that he's right. It seems like this formula works because a sub n minus 1 is the result of appending 1s to all the elements in a sub 4. You're only joking? Yeah, sure, sure. A sub n minus 3 is the result of appending 3s to all the elements in a sub 2. And a sub n minus 4, the result of appending 4s to all the elements in a sub 1. And I was right, if anyone on beach trip with I that one time and I was left. Oh, ha, I get it. I'm sure you were all right, though. This pattern does apply to higher values of n, but I didn't check it thoroughly. It would also work if you prepend instead of append. Okay. I think that's good enough. I'm glad I remembered to come back to that problem. Shit, that equation wasn't obvious to me either in general, even when I drew out the examples. Okay, let's post this. Watch that someone else posted a way better answer. Nope. Okay. Oh, no. What? Oh, wait, underscores? What went wrong with the formatting? I italicized it somehow, but I didn't put stars anywhere, did I? Look into RES between streams. I don't have that much of a problem with, like, as it is now. I guess I've never felt like there's anything that I need to fix with this, at least the old Reddit format. Wait, so why is this italicized? It starts at the 5. I never put a star there, though. Why are the underscores? It must be. I don't know why. Let's try. Okay, we can just put the escape character. Don't ask me why that's necessary. It's annoying. I don't think I've had that problem before. I missed one right there. I should have missed 2 because it would have to be closed, right? Maybe not. Okay. Annoying. We got it though. We do have two males. Oh, this is we got 2 replies to the same thing. The answer is 75. I can't figure out with proper expression that works. Thank you. They posted this one after. Okay, so I assume that they're okay then. Program is fairly simple. You just add a 1, 3 to 4 to recursively, add a 1 to a variable Oh, I guess so. With the way that Jed said, it wouldn't be that hard to get each iteration. Okay. Was I was in Learn Math. Okay. Solving system of equations without using reciprocal identities. Ugh. Okay. Reduced row echelon form for a system of linear equations. Oh god, I was always so bad at this part. Wait, I have another reply now. What's this? Oh, wow, that person got back to me quick. I guess they understood it. Okay. A plus C plus E. Don't you get them both in terms of what they have in common, or... God dang it. I don't remember this well enough. What is this called? Matrix Gaussian elimination? I think. I seem to remember the interpretation of it at the end. I remember like the method. Just not when you have infinitely many solutions, how you get the form of those solutions. This one has no solutions because 0 doesn't equal 4. Oh, that's the only example they give? Okay. Thanks a lot, website. I have never understood Wolfram's explanations. I don't usually go there if I want to actually understand something. They're always very like weird and short to me. I assume if you have more knowledge than I do that you can understand their explanations. I certainly don't have enough knowledge though. Ugh. Just show me an example of what I want. All right, that's a no. Okay, infinite set of solutions. Here we go. And so they get you said z equals t. Go do the task. So what do you do when it's multidimensional though? Do you have like would you use like t and s or like whatever u v? No, you would don't you only have one free variable, or can you have multiple free variables? I think maybe you can have multiple free variables. Two parameter set of solutions. Okay, yeah, so you do S and T. You do. That's what you do. Maybe I should just link them to this page. Because they don't really post the actual question that they have. So let's just link them to this page. 1.3.8. Is a linear manifold. See, that's where I tap out. The word manifold. I mean, it depends on what like order, because I think if this is the first one, you solve it for x, and then you get like 3 variables on the other side. And then you would just, whatever ones of those are free variables, you plug in parameters for. If it's not, you plug in, like, it makes sense in my head, but it's hard for me to explain. I should actually make that a link. But yeah, my linear algebra is really rusty, so that's why I sometimes struggle with these simple ones. This link isn't going to work. I probably need to escape those parentheses. I don't know who puts parentheses inside of a link. The site always does it, and I wish they didn't. Inside of a URL in 1.3.8 towards the bottom. Nearly at the bottom of the page. Because if they don't post the actual problem, I can't really help them out specifically. Let's make sure the link works. It does. Okay. URL encode decode. Is that like a shortener? Shortened URLs are kind of sketchy. I wouldn't want to ask someone else to click on one. Let's look at what Jed posted. Oh, well. Oh God, Jed, what are you doing to me? This is even worse than what Drew has said. Well, I think it's the bottles. Oops. They explicitly say bottles right there. Now, do you assume that they're like... It seems it depends on how you arrange the bottles, right? Depending on how specific you want to get with it. Do both have to remain intact? Oh, I hope so. So we're making assumptions about can be arranged in a way where there's no empty space. Okay, yeah. Okay. I haven't read all 3 of your questions yet. So you could get an underestimate if you assume that they're basically rectangular prisms. Like the smallest one that would contain the bottle. Yeah, that seems weird to me. Because if you're doing like it's some kind of weird Scrooge McDuck thing, you probably would get quite a few cuts. Olympics where athletes swim in wine. That would be a sport. It's Greek wine? What's special about Greek wine? I never heard of wine from Greece, but I'm sure they make it. Oh, because it's the Olympics. I see. Greece. Oh, they're not asking about filling one Olympic-sized swimming pool. They want. Given 5.1 million wine bottles, how many Olympic-sized swimming pools? Oh my God. Oh God, swimming in olive oil? Dude, if it's nice olive oil, I'd try that. $88,000 cubic feet for the pool. Okay, so they do assume the bottles are rectangular prisms. They don't give... this must be inches if they get... How do they get such a small cubic footage with numbers like these? I guess that makes sense. If these are inches, that's just weird. You wouldn't need a separate wrestling team. Just so yeah. And also, when you take a shower afterwards, you don't want like normal soap. You need some dish soap or something. I think their math is right. That seems pretty accurate, or at least the way that they've done it. Because first you figure out how many it takes to fill one pool. So you do the total volume divided by the volume for just one. So you end up with 1,200,000 bottles. Wait, 5.1 million wine bottles. That turns into 5,190,000. Okay. Gorgeous tunes. Yeah. Does olive oil, olive oil in a pan prevents food from burning. So does olive oil on your skin prevent your skin from sunburning? Okay, I mean, this is definitely a goofy problem. I haven't verified their numbers, but their method seems right. Hmm. Uh, yeah, they use these dimensions, I assume in inches, to get this volume, assuming that it's a rectangular prism. And they use it down here to figure out how many bottles fit into one pool. Oh, wait, no. Oh, I see what you mean, Jed. Yeah. Metric would definitely be helpful for that, but we don't get to use metric except for there for whatever reason. Understands your feet or inches. I mean, the 750 milliliters, it should be smaller than the cubic feet. Okay, let's Wolfram. 0.026. Yeah. So you could do the same calculation, but using the 750 milliliters of wine that a bottle can contain, and you're just discarding the thickness of the glass, I guess. Haywood, wait. Is that a D's nuts joke? I don't trust you. I don't want to get D's nuts. I know what that is, Drew. I don't know that. I don't remember a song with that lyric, but I'm still not, or with those lyrics, but I'm still not sure if you're tricking me or not. Rectangular prism is the right word, right? I keep on saying it, just assuming it's right. It's a three-dimensional rectangle. Okay, yes. On every inch of my nerves. Ah, okay. It's actually a song? Oh, okay. Okay. I think that's all that we need to say about this problem.